Hello all, I am Visaha and I am here to present my embedded system project implementation of microwave oven stimulation. Learning outcomes. The fields which we learn during this internship are C programming, embedded system architecture, microcontrollers and microprocessor, MP-Lab simulator and PiximLab. Tools and platforms used. We used MP-Lab to develop our code for this project and PiximLab for our project implementation. PIC16F877A is the microcontroller we used for this project. Implementation of microwave oven. In order to execute our microwave oven project, we need to implement CLCD, matrix keypad, ISR, switches, timers. Understanding of C programming for embedded system. The concepts we covered in C programming during the internship are basics of C programming program, structure and embedded compilation process, data types, variables, constants and memory usage, conditional statements, loops, and switch case for program control, implementation of function and modular programming techniques, application of pointers and arrays for efficient memory handling, use of bitwise operation for register level control. Embedded C concepts including header files, macros and hardware libraries, application of C programming in hardware interface and device control. Knowledge of embedded system architecture. An embedded system is a special purpose computer system that integrates hardware and software to perform a specific dedicated function within a larger system. It is designed to operate with limited resources and often function in real-time condition, ensuring efficient and reliable operation for a defined task. Components of an embedded system are microcontroller or microprocessor, memory unit, input devices such as sensors, switches, keypads, output devices such as displays, LEDs, motors, buzzers, actuators, embedded software, firmware, program code controlling the system, input and output interfaces, ports and communication lines, timers and counters for time-based operation. Power supply unit provides regulated power to the system. Microcontroller. A microcontroller is a single integrated chip that contains a processor, memory and input and output peripherals used to control a specific embedded application. It is designed for dedicated tasks, low power consumption and real-time control in embedded system. Microprocessor. A microprocessor is a general purpose processing unit that performs computation and control operation but requires external memory and peripherals for complete system operation. It is mainly used in high processing application where flexibility and performance are required. Simulation using MP-Lab. MP-Lab IDE is used as a development and a simulation platform for writing, compiling and testing embedded C program for microcontroller based system. Functions of MP-Lab in the project: writing and editing embedded C source code, compiling and building the program, debugging code using simulation tools, monitoring register values and variables, testing program flow without hardware, verifying logic and control sequence, simulating microcontroller behavior before deployment. Simulation and testing using PiximLab. PiximLab is a microcontroller simulation environment used to test embedded program with virtual hardware components. Functions of PiximLab: virtual simulation of microcontroller circuit, testing of input and output operation, interfacing of CLCD, keypad, switches, LEDs in simulation, real-time monitoring of output behavior, debugging logic errors through simulation output, verifying system response before real hardware use. PIC Genius PIC16F877A is the microcontroller we used for implementing our project in PICSimLab. Project requirement. The requirement for the project is to implement 4 microwave oven function modes, which are micro mode which is used for baking bread and pastries. It allows the user to set the time. Grill mode which is used for grilling meat. Similar function of micro mode as it allows the user to set the time. Convection mode in which the temperature can be set for preheating. Once preheating is done, user can set the time as in the other two modes. Start mode. This mode will start microwave oven with default 30-second time clock. CLCD. Character LCD. A CLCD is used as an output display module to present system information and user interaction messages in real time. Functions of CLCD in the system. Displaying system modes and operational states, showing user inputs and selections, indicating process status and messages, providing real-time feedback to the user, displaying control parameters and outputs, supporting menu-based interaction. 16x2 is the CLCD we used for this project. Matrix keypad. A matrix keypad serves as the user input module, allowing the user to interact with the system and control its operation. Role of matrix keypad in the system. Used for entering user inputs, supports mode selection and navigation, enables parameter setting and value entry, provides control command to the system, act as the main human system interface. Used for triggering functional operations. Interrupt service routine ISR. An ISR is used to handle priority events and control system flow during real-time operation. Role of ISR in the system. Handles time-critical events, provides immediate system response, control asynchronous operation, manages event-based execution, supports real-time decision-making, maintains system stability and timing control. Timers. Timers are used to manage time-based operation and control system timing. Role of timers in the system. Generation of delays, timing control of system processes, scheduling of operation and events, supporting real-time execution, synchronization of system activities, control of process sequencing. Switches. Switches are used as manual input control for direct interaction with the system. Role of switches in the system. Providing manual user input, triggering system function, mode selection and control, emergency or direct control operation, enabling simple hardware level interaction, supporting basic system commands. These are the components of the system microwave oven we have implemented in our project. Project demo. Moving to the project demo part, in MPLAB IDE, we have developed the code for our project in the peripherals microoven.c, microoven.h, and we have developed the components of our project using C programming code, CLCD, matrix keypad, ISR, and timers. Now, moving to the implementation part, we have to implement our code which we developed using MPLAB in PICSimLab. As we mentioned earlier in the project requirements, the microwave oven has to function in 4 different modes, which are micro mode, grill mode, convection mode and start mode. Let us start with micro mode by pressing 1 in the keypad. It allows the user to set time for operation of oven. I am setting 1 minute. Now when I press enter, the operation starts. As we see in the display, time is down counting and the fan indicates the operation of oven. When I press 5 in keypad, the operation is paused. And when I press 4 in the keypad, paused operation resumes. And if I press 6 in the keypad, the operation stops and takes me to the mode selection screen. Now moving to the second mode, which is grill mode, by selecting 2 in the keypad. The similar operation as we saw in micro mode can be done in this grill mode also. Now I am setting 5 seconds in grill mode. When I press enter, the operation starts. When the operation finishes, it displays timer, enjoy your meal and takes us to the mode selection screen. Now moving to the third mode, which is convection mode. The user is allowed to set the temperature to initialize preheating, and the preheating is done for a minute. I am setting the temperature for 125 degrees Celsius, and when I give enter, the preheating is done for a minute. Once the preheating is completed, the same time setting operation is done. And once again the same process happens. As we mentioned about the start, stop and pause keys, the asterisk symbol or the star symbol is used for clearing the input we have to give. This is the completion screen. Moving on to the final mode, which is start mode. By pressing the key 4, in start mode, it will start the microwave oven operation with the default 30-second time clock. Now, when I press 4 in the keypad, another 30 seconds is added for the process and the process continues. As in other modes, we can also start, stop and pause the process in this mode also. So hence, these are the modes which we have to implement in our project microwave oven, and these 4 modes are the functions of our microwave oven. I want to thank all the staffs and mentors of Emertxe for giving me this wonderful opportunity. Thank you all.